would say time to start. Good afternoon, everyone. Of course, very warm welcome to those who came in Sala Consiglio, Mechanical Engineering Department, and also to those who are attending online. I'm Gaetano Cascini. I'm Squarcio Camari. Of course, we are both professors here at the Mechanical Engineering Department of Polytechnic Milano, and somehow we are sharing the responsibility of coordinating this track of the new master degree in mechanical engineering dedicated to bioinspired engineering. So our idea for today is to make a relatively short presentation, about 20 minutes, on the track, the motivation behind what you are expected to learn by following this track and how the track is structured. Clearly, it would be very nice to have a discussion at the end with questions, clarifications, any comment you would like to make. So I don't know how familiar you are with the concept of bioinspiration and biomimetics. Some of you probably are if you are attending. Let us summarize in a few slides what is behind. So the starting point is the following. To a certain extent, we can claim that nature solves the same kind of problems that human beings address since ages. I mean, if you think, what sort of problems living organisms have? First of all, they need to access to energy. Interesting to say, the only kind of energy that living organisms do not use apart from human beings is combustion, because we are the only species who use combustion, and this should make us reflect. But all the other forms, solar energy, or the flow of air, wind, or water, this is something that normally living organisms use, or even chemical processing, so chemical reactions. This is something that they do. They need to access water. This is absolutely essential on the Earth for life. So search for water, managing water in general is a problem to address in nature. They build structures, very nice structures actually, and there is a lot to learn about the structures that living organisms produce. They process materials. I mean, there are a lot of very nice transformations in nature of how materials are used to produce very nice artifacts, we might say. And last but not least, they manage flows. I mean, there are very nice examples of what living organisms do to direct flows, to control flows, and to obtain these kind of results. Now, in this perspective, we are very similar. On another perspective, if we compare natural solutions, let's say, or natural strategies, which are the product of an evolution of 3.8 billion years of life on the Earth, and as we do, well, there are huge differences. I mean, a few examples, but very, very high level to understand. As human beings, we use the very same resources and we distribute them globally. We go for oil and we bring oil everywhere. We go for whatever other source, I mean, very rare materials, and we bring the same materials everywhere. What nature does, nature just uses local resources which are renewable. And all living organisms, as far as we don't change the environment, they use existing resources that exist locally and in a renewable way. Second, how are our processes shaped? The typical expression is heat, beat, and treat processes. We normally tend to heat materials to modify them. I mean, our metallurgical processes, just to mention one, are based on melting. We have a lot of beating, a lot of high pressure. We use a lot of pressure for transforming materials. And we use chemical treatments, which have, among the other consequences, a lot of toxic contaminants in the environment. Nature is just the opposite. Non-toxic materials used for processing and in ambient conditions, in the conditions which are available in that specific environment. One more, our processes are traditionally linear, which means that at the end of the process, there is a release of waste. This is in the human history a typical thing, which while we know that in nature, all processes are closed loop, which means, sorry, closed loop and not closed loops, which means that they are circuits. And it means that resources can be reused and reused and reused forever. And maybe last but not least, our most advanced technologies, and I must say that unfortunately, to a certain extent, also the electric revolution we are observing today suffers from the same things. We use a lot of rare materials. Rare earth is the typical chemical element used in say most advanced technologies, electronics, electric motors, and so forth. While typical solutions in nature are based on elements which are very much abundant on Earth: carbon, hydrogen, nitrogen, oxygen. If you consider the percentage of natural natural materials made of these four elements, it is more than 70%. Nevertheless, we go and use more rare elements. This is not fully a sensible thing.
So according to what Gaetano said till now, it seems that there is a large distinction between what nature does and what we generally do. Okay, so after this couple of slides, it would be interesting for us to share and to show you some, in fact, products and researches that, according to the bio-inspired approach, brought to very, very interesting results. This is probably the most famous example of a technological solution that took inspiration from nature. This is a high-speed train. I can't, in fact, tell the right name because it's a Japanese train. But the guy who designed this train faced some problem during the operational train, because due to the shape of the train itself, in some applications, in some cases, especially when the train was passing through tunnels, a very loud noise was heard, and this problem affected the operation of the train. So he started thinking on how the train itself could be improved, and in fact, the story tells that he was a bird watcher, and during his free time, he observed that there is a nice bird, this one, the kingfisher, that was able to pass from air to water without doing any splash. Okay, so he said, if the bird is able to do this, my train could do this, the same, okay, if its shape is well designed. And in fact, he did some changes, and now the train is fully operating, and he solved in a very smart way the problem. This is probably the most famous products that took inspiration from nature, but there are several others, and we will see during this presentation that bio-inspired approach is something that can be easily and profitably adapted to a very large number of fields and applications. This is another commercial robot Actually, it's an end effector for a robot that has been developed by FEST company, a German company that works with automation and robots. And they took inspiration from how this animal, the tongue of the animal, in fact, is able to grasp insects with very different shape to develop a system that, again, is able to took and to manipulate very different products by adapting its shape exactly as the tongue of the chameleon, I guess it's the right word, does. Completely different field. This, we are talking about materials and structures. So again, here, the guy who invented honeycomb, and he in fact became very rich, he just observed that in nature, there are some structures like the hive that is made of cells with a specific shape that is hexagon. Okay, this shape has a nice property to maximize the volume that is inside the shape with respect to the surface of the shape itself. Okay, so
now it's common knowledge.
Now it is, but some decades ago, no one thought about this. He was the first, and in fact, he became rich by adapting this very simple natural solution into a real product, something that's nowadays is used everywhere. Again, some other fields of application. This is a research did by Siemens company. Siemens, you know, it's a company that works in a very large number of fields. We are talking about wind turbines. A huge problem in this field is that blades, as they are moving, are producing noise, okay, due to the interaction with the air. So these guys try to find in nature which animal, in fact, is able to move in air, through air, without doing any noise. And they found that, due to its behavior, he is a hunter and he hunts during night, so he has to be very, very silent. So they understood this and they adapted the way in which the wing of the owl is able to move the animal without producing any noise to the wind turbine, so to have a system, a mechanical system that adapts this nice behavior and is able to provide a working condition without producing any noise. But there are also some research studies, not just products. There are some research studies that are very interesting. This is something that is quite far from what we as mechanical engineers do, but it's a common problem of our daily life. Okay, if you look at the picture to the right, this is very similar to what we do every day. We spend a lot of time stuck in the traffic in our car, and if we see in nature, there are some animals like ants, for example, that can move freely in a very in a very coordinated way, and they do not face the same problem we face every day. So it would be nice to understand how they are able to do this and to adapt this behavior to solve some real problems we have every day. A lot of other fields. This is, for example, related to how it's possible to increase the efficiency of locomotion in water. So we spend a lot of energy to move in water, but actually that energy is mostly used to move the water itself. So when you see boats on the seaside, you see they produce large waves. That means we have a lot of kinetic energy that is wasted. Okay, so probably it exists a way that is smarter to move things. And in nature, there are no animals or no living beings that have propellers or that have wheels or something like that. It means that probably it exists a different way, or let me say, different from those ways that we generally exploit to move something in water, on the ground, or on air. And we could take inspiration from this. Okay, obviously, it's not just a matter of imagination. It's a matter of use the tools and the knowledge we have as mechanical engineer, or in general as engineer, to approach that problem and to solve that problem. So that's the reason why we put this slide, to show you that it's possible, for example, to understand and to model the behavior of a manta ray, in this case, that is the animal that moves in water with a very high efficiency, to evaluate why, or better, first to understand why this animal is able to have this nice behavior, and then to understand these principles and adapt this principle to have something, a product, or maybe the ship of the future that exploits some similar behavior to have higher efficiency in motion. Or again, some other interesting stuffs are related to how plants are growing. Okay, we generally, when we consider mechanical devices, but in general, everything we have in life and we use during our daily life, it's we are always considering objects that have this very same dimension from the very beginning to the end of their life. Okay, we have the laptop, the house, but in nature, things are growing, so they are changing their shapes. They are developing together with the surroundings. Okay, so it's nice, for example, to understand how plants are growing into the soil, how roots are growing, because it would be something that we could exploit to develop some devices or some application to explore the underground. And this is very interesting, for example, for oil companies or for all the other applications that requires to move underground. So you can see that there are a lot of different fields where bioinspiration can be profitably used both for products and research studies.
Yep. So maybe in a nutshell, if you want to go back for all the examples we made, what's the point? The underlying process could be somehow simply represented as a sequence like this. It's a matter of understanding what is the function we want to deliver, what is the type of property that we want to embed in a technical system. So the first point is to make a search. Once we have retrieved a biological example, then it's a matter of interpreting the biological example to recognize what's the principle behind. And the principle is then translated and adapted into an aqua solution. I would like to stress here that this is the reason why we say bioinspiration more than biomimetics. Biomimetics is fine, but often, and we'll see also another example later, biomimetics is a bit too complicated for us because natural structures sometimes are not easy. But we can take inspiration from nature and do something which is convenient with our local resources, rather than as if they were implemented by nature. This is the super famous example of the Velcro, and you might probably know that Velcro was invented by observing how cocoa bars stick to wool or to also the hair of dogs, for instance. And after spending too many hours cleaning the hair of the dog, by observing at a small scale how these temporary attachment, temporary connection happens, they understood that it is a matter of kind of tiny hooks that grasp some sort of filament. And once I understood the principle, then I can adapt it into an system. And the interesting to say is that despite discoveries could not be patented, but if I make this kind of translation of a natural principle into an actual technical solution, this could be also object, if you wish, in a patent application, in a successful. What are the fields? Clearly, as you just search the internet, you will see that the first examples of bioinspiration were done in the aerospace industry. But nowadays, you have proofs of actual usage of bioinspiration in so many different fields. I want to go fast here, but I mean, it could be in design, generally speaking, of protective equipment. This is for sport. It could be also for safety in say working environments where there are risks. Biomedical field, the biomedical field has plenty of examples of artificial devices which have been created, trying in this case to mimic. In this case, it's really mimicking. Sport, I don't know how many of you are fond of swimming or cycling, but well, it's well known the much higher efficiency of swimming suits that reproduce the shark skins effect to reduce the friction, water flow. Or maybe you heard a few months ago, it was September, October, there was a new record of the 1 hour distance covered by bike indoor. And well, among the others, this bicycle has the support of the saddle, which has the same kind of tubercles that are characterizing the fins of the whale to reduce the effect of turbulence and overall reducing drag. And the same in architecture, materials, robotics, aerospace. These are some of these are already commercial solutions largely implemented, and also in other fields. So just to say that the reason to introduce this track in the mechanical engineering study program is because there are evidence from many different sources, business-oriented source, of the amazing growth of the turnover in any field concerning the exploitation of bioinspired solutions, right? Both in terms of new inventions, in terms of revenues. They are all talking about 1 to orders of magnitude of growth in the next 10 years. And so for your professional life, it should be a kind of investment. If these are the industries, what are the roles? Well, it is just a matter of fantasy, because it's I mean, you understand that any role that goes from research, as we said, goes from studying to consultancy, to development of solutions, so engineering offices, design offices, to also to optimization of engineering processes, even in production. All of them would benefit of this kind of competences, which is very much horizontal. So it allows really to spend the competences in different fields. And we will provide more details on the courses available, but I can anticipate that with the content we are delivering, there are also some specialistic one, for instance, about intellectual property, because since we claim that we are giving the skills to generate a lot of intellectual property, so original knowledge. It would be nice that at least you know the criteria to protect your outcomes, your achievements.
Okay, so now it's time just to show you what you will see during this track. Actually, let us start from the end. So let's start from showing you some theses that are available and some theses that in previous year have been addressed by mechanical engineering, but that are definitely focused on bioinspired application. I'm showing you a couple of slides related to some theses developed in the field of bioinspired robotics. So this is, for example, an activity that some students did a few years ago, and it is about the development of a robot. It's like the drones you see in air, but this is a robot that moves under water. The point here is that we need to have a very smart way to move in water. We can't spend too much energy, and we can't waste energy to move in water, and we need very high maneuverability. So we looked in nature which animal was able to do this, so to have to move in water, doing very complex maneuver and with a very high efficiency. So we took inspiration from manta ray. We developed some. When I say we, I mean the students who graduated did some studies. So they analyzed the way in which this robot move. So the animal moves, and then the robot is supposed to do. They design a new version and a prototype of the robots. They did the mechanical design, but also they did some dynamic models to evaluate with the tools we have as engineers, the ability of the robot, in fact, to perform that specific task, and then they realized the robot. In the same field, just to say how complex this field is, the same field, some other students perform some analysis to evaluate how the shape of the fin of the manta is supposed to be according to its ability to transmit the motion, to be flexible enough but not too much flexible, and to move the right way in water. Because when we design something by looking and by taking inspiration from nature, we have to consider that the very same product, very same system should have similar abilities, but in that specific environment. Okay, so a robot that moves in water has that shape that must be completely different if the same robot is supposed to move in a different environment. So we did some experiments, and students were able to design some prototypes, different prototypes I'm showing you later on in the next slides, that are in fact able to move in water and to perform some tasks like the exploration of sea depth.
Another kind of thesis concerns problem solving, making use of solutions and strategies taken from nature. I guess you know what this animal is. The English name is hedgehog. Hedgehog. Well, you might know that the hedgehog is kind of blind, meaning that if you put a hedgehog on a table, the hedgehog might fall down without recognizing that there is an edge here. Okay. So the trick that the hedgehog uses not to suicide, is is that they make a sort of ball with all the spines all around. For this reason, the spines of hedgehogs have been studied for long in order to understand what's the trick. Because the point is that the hedgehog forms, the spines the forms undergo a buckling defection. They dissipate a lot of energy, but they preserve the internal organs, which is the point. I mean, spines could be substituted. The heart, not much. That's the point. Now, here I want to stress what's the meaning of bioinspiration rather than biomimicry. I mean, you can, biomimetics, sorry. You can mimic the structure of the internal section of the spine by additive manufacturing. You can do, but it is, of course, quite expensive, at least so far. But the point is that what the hedgehog does is having long nails that undergo buckling and with a behavior that implies a lot of energy deformation. In mechanical engineering, we know that this just means having hysteresis in the materials. So you can have much simpler spines, not made with this kind of section, but made of super elastic materials that in the cycle have a lot of hysteresis. And this is, in brief, the kind of results in terms of total energy they can dissipate, or total number of hits this kind of shock absorbers could withstand without fading, before fading, which is very simple. So this is just to say that once you understand the logic behind, you can really import it and adapt it to your specific. Another example of thesis took explanation from another animal. Can you recognize this one? Maybe here. Okay, now you know. Calamari, we have several kinds of calamari. You probably know that especially some of them more than others tend to change colors to adapt to the colors of the surrounding, like chameleons underwater. Now, among there are a lot of studies about how animals change color, and it is super fascinating. Among the techniques, the one adopted by calamari, I won't make it too long, but consists in having kind of nano cuts at nanoscale, which under deformation reveal a color which is underneath. Okay, so based on how much they pump themselves, they can reveal a color which is underneath. And this is, controlling this pressure, they also control their color. We decided to adopt this mechanism, not with nano cuts, which would be too much expensive. It is sufficient to have cuts of the size of 1/10 of a millimeter that we can realize in our laboratory with water jet, and combining with our mechanical engineering knowledge of metamaterials, so that if you cut properly a thin layer of something which is deformable, with, let me say, some cuts that determine the behavior of this layer as a nanomaterial, then what it is possible to do is to make a detector of deformation by color applications. This is the simplest one, but the point is, for instance, instead of controlling by sensors, if you tighten enough the clamp, you just see when the color changes, you're done. And just to let you know, in the thesis where we developed this one, it is possible to notice the color change with a deformation of 3% that by the naked eye you will never. Just to give you. Let's go to the laboratories.
Yeah, okay. So together with the thesis, you have other opportunities to see in practice what taking inspiration from nature means. And we have, this course, in fact, had has two laboratories. So for those of you who are attending this track, we will see you in these two labs.
At least in my lab.
At least in the lab. The first is about bioinspiration in robotics. So we are working with you to develop and to test robots that, in fact, are taking inspiration from nature to solve some specific problem. Okay, one of the most interesting problems for us is to move. Okay, in different environments, water, for example. So you will develop and you will test some robots, some already existing, some other will be up to you to be to design and to prototype this robot. Here, just a couple of examples of robots we developed and robots that will be available in the lab. This is a small scale robot of Monterey that we designed and tested. The activity is started from the scratch, so to evaluate in nature how animals behave, then to understand the principle that is behind that behavior, then the adaptation and the that parts that for us as engineers is probably more interesting. That is how to in fact apply and how to put in practice the knowledge we have from the let me say the biological solution we understood, we analyzed. And this is exactly what you will do in the lab. So from the very beginning to the end, so to the typing of robot and its testing in natural environments. And same is for other application. This is a spider robot. So a robot that took inspiration from spider. This is a very common solution for robots moving on non-structured grounds. So again, here is the activities are based on all the typical problems of we face as an engineer. For example, those related to the kinematics of a robot, the dynamics of the robots, the control of the robot. So it's very interesting, for example, for this device that has a very large number of degrees of freedom to evaluate how control them and how improve the attitude, for example, of the robots or its behavior when it moves on complex ground. So we have a large number of variables we can measure, that we can control, that we can actuate. Okay, so it's a very complex task, and you see here in the lab the robots moving on different terrains we have available. And some other application. This is a snake robot that you see has been designed in a very simple way by students, and same is the same for design is for control. So when you will be in the lab, go directly hands-on the robot to check how the robot works, to improve their mechanical parts, to improve the control, or to write down new algorithms to let the robot move, and so on. Okay, so all the different problems related to robotics are faced with the approach that is the bioinspired approach.
Okay. The other laboratory, the one on prototyping bioinspired solutions, for the start, we'll have two kinds of activities. One is related to bioinspired materials. There are a lot of already commercially available bioinspired materials on how to exploit their properties into technical solutions. I'm not going to present that part. You can figure out more clearly what it is about. The other one is again inspired by Manta. Manta is a quite successful living organism in bioinspiration, for a different reason. Manta, to feed themselves, they actually make seawater pass through these channels, through these branches, with the idea of course, grasping all particles of plankton that are, actually their food. So by studying how manta feed themselves, you can recognize the different filtering mechanisms which exist in nature. Specifically, the mechanism exploited by manta is, say, in a schematic manner, this one, meaning that particles, by means of some sort of turbulence which is created by uh, that sort of structure, particles are accumulating behind these ribs, and eventually you can just pull them away from behind the ribs and pull them away. Why is it useful? For instance, what we did was to make a proof of concept of a filter suitable for grasping microplastics. So you know already microplastics, you heard that they are one of the most critical pollutants in the oceans, in seas, and as we more and more are eating plastics instead of sea bass or generally fishes, this might be a way to have a nice catcher of microplastics without a mesh, because the point of the traditional filters is that they get clogged very easily when you go with so tiny particles. So, but why this is a laboratory? Because what we are building now, and it will be ready for the laboratory when it starts, it's a test rig where we can control flow, direction, and a lot of things with a test section where you will be invited to design and produced by additive manufacturing, either filters or valves. These are two examples of previous studies. So a kind of tricuspid valve as the one of the Earth and the filter of the microplastics. But in principle, the same test bench could be used for any sort of valve or filter by Inspired. So the idea that you design it, you manufacture it, you test it, and you compare it. So in order to arrive to the prototypes, you need to attend some course.
Yeah, we are finally two more slides. We were supposed to just finish this presentation 20 minutes ago, but okay. So this is, I promised you the last couple of slides. That is in fact how the track is, okay, in terms of courses you are supposed to attend. So if you checked the other courses, you see that pretty much the structure of each track is the same. So we have some courses that are mandatory, okay, for, let's say, 40 credits, okay. So these courses are mandatory for this specific task, this specific track. So each track has its mandatory courses, okay, so they are different from track to track. You see here which are that don't want to go into detail, otherwise we stay here for another 40 minutes. We have some courses, one for this track that is a course that is very, very specific for this track and that we consider as mandatory because it provides you the knowledge to approach all the other courses. Okay, that is Bioinspired Design and Robotics. Okay, so this is a course that is specific for this track, that is mandatory, and it provides you the basic knowledge for all the other courses. Then you can choose for the first year and then for the second between some courses that are offered to you. Okay, you can pick them and you can create your specific track. Okay, so according to your interest or according to what you want to do in your future working life and so on. So you see, for example, in year one, you have 10 credits of courses that you can choose between these 5 courses you have listed here. Okay, so you see from this picture, and then I will show you the year two, that courses are about very different fields. And that is because from the very beginning, we told you that bio-inspired approach is something that can be suitably used for a very different number of application, field studies, researches, and so on. Okay, so you see, for example, that we have courses of materials, courses of measurements, courses of manufacturing. So something completely different, or let me say, in very different fields of application. Same is for year two. Actually, here you can choose 30 credits of different courses. Again, the idea is the same, different fields, and you can pick up the courses you prefer or those that are closer to your interest. This is for the first 30 credits of year two, and then you have the opportunity, exactly as you have for all the other tracks, to choose one open course for 5 credits. Okay, this open course is a course that can be chosen between all the courses available here at Polimi. Okay, that is because we believe that it's important for you to at least for this small number of credits, to see something different. Okay, and this is the reason why we have and you have this open course. So it's an opportunity for you to explore, as Gaetano said, something completely different: architecture, chemical, or who knows. Okay, and then you have this the choice between these 2 labs available. Till now we have these 2 labs, but in future maybe we will have more. So you can choose between these 2 labs for they have the final 5 credits.
Yeah, and let me say, if you really don't know which of the 2 labs to attend, in principle, you could use as open course the other lab. It's 5 credits. So, I mean, being free, being open, I'm not suggesting this. I mean, it is nice if you go and explore elsewhere, but if you really are struggling how to do this, I have 2 laboratories, I want to attend both of them, but in principle, you could.
And then, of course, you have the other 20 credits that are related to the thesis. So yeah, this is how the track is structured. Again, I'm not going in detail on how courses are. If you're interested, we can discuss about them, but this is just a brief overview of the track. Obviously, you can find all this information on the website together with this presentation. And here you have our contacts. So for all the questions or for doubts or everything, you can write us an email and we will do our best to answer.
That's it.
Yeah, I guess we thank you guys for
for the patience.
Yeah, for being here till the end. If you have questions.
Also about the courses, if there are questions about the course or about the laboratories, about physics, about
Surat domanda online.
when courses program will be available manifesto di studi. Riccardo, so for what concerns the courses which are already available already nowadays in this academic year in other study programs or in the mechanical engineering one, you can search already And of course, I mean, they won't change too much. But what concerns the new ones, by the rules of Politecnico, we are supposed to upload the descriptions by, I would say, end of June, mid of July at latest.
But this is for year one.
For year one, so
Yes,
I mean,
those
the courses which are about to start in September. Then I would say that if you, by the way, have questions about a specific one, just ask us now or later by email. And since we know already who is the professor who is going to deliver the course, the easiest thing I would say is to get in contact with the professor, and they can tell you, okay, in I don't know, in just say by random choice, efficient and frugal design and innovation. What is the topic? This does not exist nowadays. Well, you go and ask Professor Beccatini and they will tell you. So course of second year will not be available next year. Riccardo, now if those courses are only for the second year, I mean, because the point is that if a course among these ones is delivered only for Bioinspired design at the second year, then it would make no sense to activate it. But if they are also part of other tracks, then it could be. Just for instance, these courses will be delivered already since the very first year. So biometric structure design, which is a course of the second year of others, another track specifically, well, this one will be already started from the next academic year. Okay, so Riccardo, you should double check which one. The track will start already next year, but of course it will start from the first. If you want to answer, since you already started and maybe I was not sufficiently exhaustive, could you please tell us a bit more about career opportunities?
Yeah, maybe we can say a couple of words. As Gaetano said, regarding career opportunities, it's something that we observe every day, that's being Bioinspired engineering, something that's say is living and it's interesting for a lot of different fields. There is a growing attention to from industries to those engineers that in fact are able to provide this knowledge to companies themselves. Okay, so it's something maybe we can add some more slides on this presentation with facts and figures from the Biomimicry Institutes that collect some data to job opportunities and so on. And it's something that it's, as Gaetano said, it's very, very, it's probably one of the fields in which we are observing the largest interest from industries for the knowledge, from skills, from the experience that those engineering working in this field can provide to companies. So it's something that for a very large variety of companies, it's something that is very, very, very interesting.
I will also say that, well, I'm sure that you will hear a lot about sustainability in all possible tracks, in all possible courses, but there is a fact. Environmental sustainability is a must. There is no way to escape it. And whatever people think about it, they can propose one or another solution. But the point is that sustainability, environmental sustainability requirements are already on the agenda of the European community, of all the multinational companies already there. It is sufficient to go search whatever large company, you search their sustainability report, and you will see that what sort of claims they are providing. Now, the point is, what are the most successful established resources we have to address environmental issues? No way. I mean, nature has the longest history and experience on what is the best way to use available resources in a renewable manner. So this is why, I mean, in terms of application fields, we are super confident of the actual usability of natural strategies. In terms of roles, it is a bit also to explore, but again, here we are providing such, let me say, a horizontal set of competencies and skills that it is really up to you to, we say, to move ahead in your career in research or in technical development and well, prove that you know how to do things. So I won't tell you job titles. Job titles would say either, whatever. Industries, the same. I don't know whether
No other questions?
Saber, this clarifies a bit, hopefully, yes.
You guys here.
Enough?
By the way, we are always available for each question or each curiosity you have on this track. Here you have contacts, but on the website you can find all the information.
Yes, so thank you for coming.
Thank you,
I mean,
guys.
we were late, but at the end it was 1 hour sharp.
Yeah.
Well done. Thank you. Thank you, guys.